Hello, everyone. In this video, we're going to look at example 3 of section 6.5 on improper integrals. All right, so in example 3, we're asked to determine if this integral from 0 to 2 of 1 over the square root of x dx converges or diverges. And if it converges, find its value. So let's first get a sense of what this integral looks like to see why it's in this section or why it's improper. All right, so let's go ahead and draw that out. So we have our set of axes here. And if we were to graph this 1 over x, or 1 over root x, kind of looks something like this. As we get close to 0, the function gets larger and larger. But at 0, it's undefined because we can't divide by 0. And then at 2, we get 1 over root 2, so down like this. And at 0, we're here. So what's the issue with computing the integral from 0 to 2 of this function? Well, 1 over root x doesn't cross the y-axis, so there's no value at x equals 0. So we have improperness in this part here. All right, so what we're going to have to do then is act like we're computing a proper integral. So I'll use t here as my variable. So computing an integral from t, it's going to be larger than 0 to 2. Okay, so let's write that out. So we're going to compute the integral from 0 to 2 of 1 over root x dx. But that's going to be the integral from t to 2 of 1 over root x dx. And now what will our limit look like? Well, we want to take that t, we want to take it to 0, but we want to take it to 0 from the right side, so from the positive direction. So here is the integral that we actually need to compute. Okay, so let's go ahead and compute this integral. We need to compute the antiderivative of 1 over root x. So that's the same thing as x to the negative 1/2. So in computing that antiderivative, let's go ahead and rewrite that limit. T goes to 0 from the positive side. Rewriting that antiderivative, we're going to add 1 to the exponent and then divide by the new exponent, or divide by that exponent. So we get x to the positive 1/2 over positive 1/2, and we're evaluating at t and 2. So let's go ahead and clean that up a little bit. So we get the limit as t goes to 0 from the positive side of 2 root x. So just changing that 1/2. We're dividing by 1/2, so it's the same as multiplying by 2. And then 1/2 in the exponent just gives us a square root. So we're evaluating at t and 2. Okay, so let's go ahead and plug in that 2 and t. So this becomes the limit as t goes to 0 from the right of 2 root 2 minus 2 root t. Okay, so what happens there? So 2 root 2, that's just a fixed number, so no big deal. But what happens to 2 root t as t goes to 0? Well, as t goes to 0, that entire term just goes to 0. No big deal. So then we subtract 2 times 0, or just 0. Right, so in the end, this limit converges to a finite number, 2 root 2. So what does that mean for our integral? So the integral converges to 2 root 2. So that means this area between that y-axis and our curve 1 over root x is a finite amount of area. All right, awesome work going through this final example in our 6.5 notes.